In this problem, a crane needs to lift a load of 2,000 newtons up 150 meters. The cable attached to the load has a weight of 22.5 newtons per meter of cable. What is the formula for work done at a given point, and what is the work done at a height of 75 meters, 150 meters, and between the height of 75 meters to 150 meters? So first we need to find the equation for work. Recall that work is force times the distance, but we have a changing force, so we need to complete the following steps. Step 1. Find the total weight to be lifted at initial state, the total weight of the load and cable. So we can take the load weight of 2,000 newtons and the cable weight of 22.5 newtons per meter times the total length of the cable of 150 meters, and we get a total weight of 5,375 newtons. Step 2. Find the equation for the weight of the cable and the load at any given height. The equation is the total weight minus the reduction of the weight of the cable, or in other words, the weight of the cable that is already pulled up. So the equation is 5,375 newtons minus 22.5 newtons per meter times y, which we will be using y for the height above the initial position of 0 meters. Step 3. Integrate the equation of the cable and load weight at a given height. To do so, we will be using the constant rule, where you multiply the constant times the variable that you're integrating with respect to, in this case y, and the power rule, where you add 1 to the power and divide by the number of the new power. We get the equation 5,375 newtons times y minus 22.5 newtons per meter times y squared over 2 equals work at a given height above the initial position. Now to find the work at the halfway up point, or 75 meters, we can simply plug in the 75 meters into the equation we found, and we get 339,843.8 joules of work completed. Note, it's worth mentioning that we are actually subtracting the initial condition from the value, but due to the initial position's work being 0, we are just plugging in the final condition into the equation. So this is the equivalent of taking the limit from 75 meters to 0 meters. Next, to find the total work, we can take the height we need to raise the load to get it to the top, which is 150 meters, and plug it into the equation. We get 553,125 joules of work needed to raise the load and cable all the way up. This is equivalent to taking the limit from 150 meters to 0 meters. Now to get the work needed to lift the load from halfway. We can take the limit of 150 meters to 75 meters. This is equivalent to taking the work at 150 meters minus the work from 75 meters. We get 213,281.2 joules of work needed to lift the load and cable from 75 meters to 150 meters. I have a poll listed on the community tab in my channel, where for every vote I get in a specific topic, I'll make a video in that topic. At this point, I've made this video for calculus, 1 for strength of materials and statics, and 2 for mechatronics. That concludes this video. Hope you'll have earned a like, share, or subscription. If you enjoyed this video, you may enjoy one of these videos as well. Let me know how I'm doing in the comments down below. Thank you for watching.